today and at least the next day of notes, maybe past that, are very, very tedious, but very repetitive. And I can guarantee you that if you try to halfway pay attention today and kind of try to pay attention to what's going on, but not really, you are going to be so lost tomorrow and not be able to even start this problem on a test. So it's not a hard problem, but it's tedious. And if you aren't paying attention, you aren't going to know what to do. It's not something you can just jump in the middle and figure it out. All right, so we've got data on, it says the number of a certain type of bacteria present in thousands, and a certain number of hours is given in the following chart. I probably should have included something more about context so I could define a population, but I didn't because I'm just trying to get a basic example here. So on notebook paper, sometimes we're going to write population above, just for the sake of it. So usually I'm going to write a population there. I just didn't go to the details of writing out more words just so we can have a population here. All right, so anytime I get a problem like this, and if you are a color person, I am using, I guess, essentially one color and a pencil, if you want to think about it that way. So I'm going to do my notes in two different colors. If you visually want to do it that way, but like not doing it doesn't matter. For every problem that we deal with regression, I talked about the last couple days. I said it gets very, very repetitive when we're answering this question because we keep saying the same context over and over. So now we're going to start with defining it initially, just like we did in the last couple chapters, like let this mean something and then keep referring to it. What are the two main things that we're going to refer to all the time? X and Y. So we are going to define an X and a Y. So for this problem, even though I didn't give you much context, which one makes more sense to be the explanatory variable? The number of hours. So under population, we're going to write that X means number of hours. So what does that leave Y to be?
Number of bacteria.
Number of a certain type of bacteria. And what else? I missed the two things. Present and in thousands. Now, we are defining this initially and referencing it a lot throughout. So make sure that you are absolutely as detailed as possible there, because we're not going to keep writing this context out over and over and over. All right, so this whole section is going to be dealing with this data. And this isn't going to make as much sense over here on the side while I'm doing this yet. But I'm saying I am dealing with my original data. And I'm in the margin right now, which is just X versus Y. All right, so we're going to think about what's in the calculator. Most of you are going to start on this line. Usually most of you are going to start on this line. I'm giving myself extra room right now. So we've got an L1, we've got an L2. And I'll tell you, writing what's in the calculator is going to help you a lot in the long run. Because otherwise you're going to get really confused with where things are. So what should we put in list 1 in general? What should we put in list 2? All right, so let's not even keep going past that yet. I'm gonna have two graphs right here, like spacing wise, just so you can see. So I'm going to do a scatter plot on this side and a residual plot over here. What am I going to do a scatter plot of? I'm doing a scatter plot of x versus y. And why can't I write just x versus y? Because I've defined it up here. For the sake of going a little quicker, go up to 18 and do 13.5. That's a 13.5, 9, 4.5, and 0, just so that we're all doing the same thing. And then do your x-axis as 1, 2, 3, 4, 5. And try to equally space it out. Usually what I do is take another sheet of paper and turn it sideways so I can use the lines on the paper to now space those equally. And go ahead and graph the however many points that we have right there. Well, let's go ahead and label together first. What am I going to put as my label down here? Super easy. Because I've already defined it. What's going to be up here? Because I've already defined it. And then go ahead and do your dots. Now I cheated and pulled up a picture behind it so you can see some words through it, but you can still get the same picture. Now, you've taken enough math classes to probably be able to look at that and tell, is that linear? What is it? Exponential. But that's going to be the first transformation that we're dealing with is exponential. So yes, you've kind of dealt with enough to know that that's the direction we're going, but that's fun. All right, so we've got our scatter plot. What's our second graph going to be? Residuals plot. So I have to use what's in my calculator up here. So list 2 is my what kind of values? Those are my observed values. And most of you are just going to write that in pencil, just it's reminding you what's in what column. So what do you think we're going to put in list? We want in list 3. Predicted, expected. And then what do you think we're going to end up putting in list 4? Residuals. But I want to write what actually is going in here. So how do I know what's actually going to go in there? How do I get predicted values always? So I need my equation to be able to plug in my equation. So what do I go through to get that? Stat calc 8. We're going to list 1 versus list 2. I bet you're doing this with me. Stat calc 8. Oh, y'all haven't plugged your numbers in yet because you haven't needed to write. Go ahead and plug your numbers in right now. Oh, they're under my jacket. Sorry. phone dead. I finally got batteries. I gotta remember to do them. Thank you. Did that one work? There we go. I think I have one more calculator out there somewhere that's dead. I guess it's still in the chair. All right, so once you all have typed in, then go to stat calc 8. You get your regression equation. And so I'm going to write what it is that I'm actually going to put in list 3, whether I do this or that other method I showed you on Friday. So in general, I'm going to go ahead and write my equation strangely over here. So I am saying this whole section is going to go with this equation. So my equation is y hat equals what?
Negative 4.274.
Negative 4.2744 plus what?
3.9433.
3.9433x. So I'm saying this equation is going with all of this. So here, for my sake, I'm going to do this as negative 4.2744 plus 3.9433 what? What's supposed to go here? Where are those? So I'm kind of showing myself on the grader what I put there, what's going to be there. What's going to be in my red words above, what do I want in list 4? Up here, what do I want? Residuals. You said, how do I find them? Observed minus predicted. Where is my observed? Where am I predicted? And so that's telling me where everything is, how it's all organized. So here, I should have given myself a little bit more room. I'm going to not get my words mixed up as much there. So I'm going to slide mine down a little bit. You don't need to. So this is going to be my residuals plot of what? X versus Y. What goes on my x-axis? What is going to go on my x-axis? My number of hours, my x. What's going to go on my y-axis? Residuals, because residual plot. And where's does my graph look like this, like a quadrant 1 kind of thing? It looks like what? It's got that line through 1 and 4, 1. And I did 3, 2, 1, 0, negative 1, negative 2, 3. Negative 3 is mine. And so you've always got the x-axis going somewhere through about the middle. And so I'm going to put x's are here. These are my residuals. And what do I know about how I'm numbering my x-axis? The exact same way that I did it over there. Now, if I'm trying to do this in my calculator, I would be doing a scatter plot of what versus what? List what versus list what? List 1 versus list 4. So go ahead and do that and then graph that. Yeah, second stat plot of list 1 versus list 4. make sure you put something in list 4. Y'all got to do the list 3, list 4 before you do it. And I kind of went through my words. I went back over mine in red dots just so that you can see it. But on your paper, you probably did fine. And I've got an overlaid graph too, so my letters are kind of getting mixed in. And so remember, the idea of what's happening in the residuals plot is taking that scatter plot, the line we think should go through it, and basically the zoomed in, exaggerated version. And so it should make sense that you would think it was going to look like this anyway. And once I'll kind of stop drawing, I'll talk about that. And I think the easiest way to do it is to do scatter plot of list 1 versus list 4 and then do trace to go through 0 to 6 points. Okay, so you want to stick it here, then scatter plot. And then, so now you're looking at these ones, right? And then now hit graph. And it's a bit zoomed on. Yeah. Okay, so you're saying that plot, you're just trying to graph it on the you did something funny here. So then, you see what I did? So when you're here, you're doing list 2. Yeah, and when I did it, it changed it, so you guys just actually touching it up in there. And then so now do second step plot of list 1 versus, or just hit graph. And then you should go these in line. You might do the line. And you can do it that way, and that's fine. But that might be a different way to do it. So she teaches it. So if you do it that way, then your residuals. Okay, then you should put this as list 4, so residuals can grab it. No, that's right. It goes in order of the order that you type them in. So that's right. Like mine, see how I've got ones that are close?
Didn't you say for list 3 we can do Y1 and this one?
You're doing, yes. Did you do that? Yes, yeah. So what, and I'm glad you said that. Remember on Friday here, I said that you could do your function of Y1. This is your function of Y1. So if you chose to do it that way, you would type in there function of Y1 versus L1, and that's absolutely fine. Alright, so just going over you understanding getting from this scatter plot to this residuals plot. The idea is if I draw a line through here, numbers that are on the ends, where should they be in relation to my residuals or to my LSRL? Numbers on the ends are where in relation to my line? Where are they? Above. Where are numbers that are in the middle?
Above.
So it's taking that idea. That idea should make. I could look at this and not maybe see that it was going to look exactly like this, but I should get that idea without drawing that line and understand, okay, the lines will go through here. The points in the middle are going to be below. The points on the ends are going to be above. All right, so with where we are right here, we now have to make our decision of do we think we're good with where we are or not? Well, how does our scatter plot look? Good or bad? What do we want? What kind of relationship do we want? Linear. Good or bad? Bad. What is good or bad about this? Is this good or bad? It's bad because it definitely has a pattern. So are we at the point where we can say these two look linear right now? No. So those of you who do color, whenever I did my colors here, so I was using my X and Y, my original data, all using this equation, and I came to a conclusion of being not linear. The relationship, we were measuring the relationship between what the whole time? So the relationship between X and Y is not linear. All right, so now we got to talk about Y. Y here. It's not linear. So the scatter plot, and I'm just going to tell you the way I usually word this, shows a slight curve. And the residuals plot. Now, how many things did I have to check for my residuals plot? 3. It needs to match all 3 of those to work. How many would it have to break to not work? 1. So I don't need to address all of them if one of them doesn't work. So the scatter plot, what? Has a distinct pattern. So it's not linear where it is. This is what's bad with my scatter plot. This is what's bad with my residuals plot. So this is not the line of best fit. Which means I have to continue or move on. As soon as I write, this is not the best line of fit, I want to mark this out, not enough to where I can't tell what it was, but enough to where if I see something in a problem that says predict, I'm very obviously not going to use that equation because that happens a lot. So putting a mark through it to show yourself, hey, don't plug anything into this equation because it's not what I'm supposed to use. All right, so basically up to this point, it's everything that we've done until now, just talking through it. So now it's what next? And now I'm going to write this on a different slide, but I'm showing you visually how I want this to go. So I just, a line or a swivel or something showing me that, hey, that all went together and now I'm starting a different one. Now, in actual statistics, there are a whole lot of different ways we can transform the data to make it work. You can take squares, you can take square roots, you can take logs, you can take cubes, you can take quadratics, but we're going to be very, very, very vague in this class and be like, this is what I think I should do first, and this is what I think I should do second, and that's all we're going to talk about. So it's not that there are only 2 options in the world. It's for the sake of this class, this is what we're talking about. So we are going to convert y as the natural log of y. We are converting y, and that's the natural log. Ln of y is natural log. So now our whole relationship is what versus what is a coordinate? X versus natural log of y. And this is where it makes a huge difference that you're keeping up with things. What's in our list 1? What's in our list 2? We are going to always use those, but then we're basically going to wipe everything after that to use something different. So now, what do you think I want in my list 3? So I want to take the natural log of list 2. So in the first problem, where were my observed? List 2. In this problem, where am I observed? It's going to be, because we are dealing with everything in terms of natural log of y, so these are now my observed. Well, I have my observed. In general, what do I definitely want? Well, let's go ahead and draw a scatter plot first. So go ahead and put this in your calculator. I go ahead and delete all my list 4 and my list 3 first, just so I don't confuse myself. And so this is going to be, what am I going to write right here? This is a scatter plot of what? So I kept telling you we were going to make everything a lot more shorthand. Just defining x and y initially makes life a whole lot easier on us for the entire problem. And I'll go ahead and tell you here, I went ahead and did 3, 2, 1, and 0 as my y. And then I kept my x the same. And then go ahead and graph that scatter plot, which is going to be list what versus list what? 1 versus 3 right now. And so I've got my ln of y as my y-axis. I've got my x's as my x-axis. So when I do list 1 versus list 3 as a scatter plot, how does that graph start to look? It definitely looks a lot better than our first one did. And I'll pull somebody's calculator up and screenshot in a second, just to make sure that you're doing the exact same thing. But I'm going to go ahead and keep doing this so that I can screenshot both of them at the same time. So pause where you are just for a second as far as graphing, and we'll keep talking through this so that we can graph all of them at the same time. So my observed are in list 3. So in general, what am I definitely going to want in list 4? Oh, and there's a natural log button. Well, in order to do predicted, I need a what? I need an equation. So now we're doing the same thing. Stat count 8 of what lists? List 1 versus list 3. And so I'm not doing it in terms of x or in terms of y. I'm doing it in terms of what? Natural log of y. So your equation actually looks like natural log of y hat equals, and then written out kind of the same way you would have before, which is negative 0.0047.
You want us graphing list 1 and list 3, right?
For this one, yeah. And 0.5860 x.
I can't graph it, it's an error.
Do you have anything in your list 3 yet?
I did that.
Just go up versus list 4 in your graph.
On my stat.
Yeah. And it hits in there. Alright, so I'm plugging in over here. In my predicted, I'm plugging in my equation. We're comparing it to a natural log, so I don't have to do anything about that when I'm plugging my equation. So I'm plugging in as negative 0.0047 plus 0.5860, and still, where are my list 1? Or where are my x's? List 1. Again, if you wanted to use that function button, the y1, maybe I would have used y2 instead at this point, but that's totally fine. And what am I going to put? My red word for list 5 is going to be what? Residuals. And how do I find, what am I going to type in list 5? And so I know I kind of sped you up just to get through this part. But then I'm going to give y'all time to start graphing things. My graph here is a residuals plot of what? X versus natural log of y. I went by 0.02 each time and did 0.04, 0.02, 0, negative 0.02, negative 0.04. I probably could have done better than that with 0.03, but it is what it is. And I'm still numbering my x-axis the same way. I haven't changed my axis at all. And so this is my x. This is, what do I label as my y-axis? Residuals. And then now I'll slow down and help answer questions whenever. I just needed to finish that top stuff so I could get through both graphs. Like I said, it gets very repetitive, but it's very tedious. And if you miss out on a piece of it, you really just can't start a problem. So if you're stuck, I want you to be talking to each other right now or bringing me over there to get it figured out. You can't get your what?
So I just deleted it.
So we would do L1 and L5.
L1, yeah. So your residuals plot will be L1 versus L5 this time.
I just deleted it. You know what? Just delete all of them. What are you talking about? Well, I know how to fix it. You have a new list.
That's the issue, is currently, it's right here, plot 3 is on, and it's trying to grab.
You know, I almost said.
That's right, that, and then I want to also get your other plot, which is going to be
Maybe it is. What did you put there?
L1 versus L5. You might just want to together.
Everything changed all of a sudden. So when I did Y1 of list 1, everything down, go back to your computer, list 5 again. You could have read it part. And then so
And you go to snap plot, and then you go to whichever one. It's like you don't.
let me know if that
So 1 is your X, 3 is your.
Anybody with questions that people around you can't figure it out, you need me, because I would much rather stop and figure it out now than later.
The scatter plot we did X versus natural upper Y, right? And for the
Yeah, so this is 1 versus 3 and this is 1 versus 7.
7.
List 1 versus 3 and list 1 versus 5.
Okay, good.
Wait, Miss Leonard, you said plus 1 versus 5.
As your residual plot.
I mean, my company has a script. Well, I have a script using it. So it's not like this. You know what? I'm gonna read it.
What did I do? And now, if I
You do L3 minus.
It's like linear. Mine doesn't. Mine looks slightly different. These are like predicted.
Oh, we're trying to figure out
C.
what's the line?
You do it, right? Yeah.
I did L3 minus L4.
Here's something like this.
Relatively small.
This one's flipped. Okay, I'll look at it.
It's the same.
That's the same.
Really? I think it was really good.
It's got two there, one down there.
Yeah, but see, her two are below the line.
These two are not.
No, that's hers too. Mine are the same pattern, but a little bit higher.
Is it greater than something?
I liked this now.
Greater. I know there's some people that
Yeah.
but that's
Go with the weak line.
all knowing shooting.
I like it.
Nobody
Oh, I always skip that one.
figure it out.
It is the last.
Negative slide. You use this for C. Imagine.
I think read it.
I go around those.
I think it's just like, I don't think they count it. It's just like the questions are like trying. I don't like them. No, I don't read it. I don't read it. It was like 16 questions.
General.
Yeah, I wish I know. I read it dual passage now. Something.
On the Y, I associating.
I tried, but I was like, man, I have no idea.
Are these 2 points above the line?
Yeah.
Okay. Just barely. Like I can't tell with where mine. It's something like that, right? Okay. Oh, it starts at 1. I think I'm a scale stretched in. Is this a point? This is a point, right? Okay, so I did have that right. All right. Yours should look something fairly close to what I have up here. So how does our scatter plot look compared to what it did look like? A lot better, right? What are things that we look for in a residuals plot? No clear pattern. What else? Equally above and below 0 for all values of x. I'll show you when I'm standing up there. It makes more sense. And then relatively small. So if we're predicting our actually, I'll come to that part in a second. So we have to do our written part below. So now, instead of not linear, we're going to write what? Linear. And we're basically going to go through the same wording, but answer it as things are better. All right, so now the relationship, what? The relationship between x and natural log of y is linear. So now we go to y. What would I say about the scatter plot? What do I want it to do? Shows a fairly linear pattern, shows a fairly straight line. Fairly straight line, fairly linear. The residual plot. And so because it does work, I would need to talk about all of them here. And so I would just mention, I would list the 3. Has no pattern. Equally scattered. Above and below 0. For all values of x. And has relatively small residuals. So the equally scattered, I'm kind of looking at all the way to the right. I'm scattered about this much. There aren't that many points. There's no points that it's like it doesn't have that cone shape. Now, when I'm talking about relatively small, here were my initial natural log of y values between 0 and 3. Are numbers up to like even less than 0.04? Are those relatively small with those numbers? Yeah. So, x versus ln of y, I might have to go to another slide. I'll just slide it all up. So x versus ln of y, x versus natural log of y, is the line of best fit. And this one you already know, which means the relationship between x and y is what? You told me this initially. Exponential. If we just make y natural log of y, the relationship between, it's always the case that if this one works out, it's exponential. Like grows exponentially like this with your curve up. Which makes sense because when you look at the picture, it looks exponential. Now, when we predict, which I'm not going to talk about today now because of time, when we predict, we plug it in, but we get, when we plug in a prediction, we get natural log of y, so we have to do something with that. What's the opposite of natural log? E. So we plug it in here and take e to that number to get what our actual predicted value is. What? It's not recording?